In this video, we're going to solve a problem taken from the JEE Advanced Examination. Find all x that satisfies both tangent x equals cotangent 5x and sine 2x equals cosine 4x. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. This is a really quick trigonometry problem as we can solve each equation separately. So for the first one, tangent x equals cotangent 5x, we can start with rewriting tangent as sine over cosine and cotangent as cosine over sine. Then we can cross multiply and we have sine 5x times sine x equals cos 5x times cos x. Then I'm going to move the sine expression to the other side. So we have cos 5x cos x minus sine 5x sine x equals 0. Now from this is actually the result of the compound angle formula. So I can work backwards and say that is equal to cosine of 5x plus x, and that's equal 0. So that means cos 6x equals 0. But for values that cosine of that equals 0, it's only pi over 2, 3 pi over 2, and adding these solutions by multiples of 2 pi, we have 5 pi over 2, 7 pi over 2, etc. And actually I can replace that as pi over 2 plus multiples of pi. So I'll write that as pi over 2 plus pi k, where k is some integer. So that is the general solution for the first equation. Now I'm going to move on to the second one. So for sine 2x equals cos 4x, I'm going to use the double angle formula on the cosine because 4x is double of 2x. So that means sine 2x equals 1 minus 2 sine squared 2x. And we have 2 sine squared 2x plus sine 2x minus 1 equals 0. Just moving everything to one side, and we have a quadratic about sine 2x. So we can factorize and we have 2 sine 2x minus 1 multiplied by sine 2x plus 1 equals 0. And that means sine 2x is either 1/2 or minus 1. For sine, solutions are again presented by numbers plus multiples of 2 pi. So for 2x, we have either pi over 6 plus multiples of 2 pi or 5 pi over 6 plus multiples of 2 pi. That's for sine of those numbers equals 1/2. While for sine some value to be equal to minus 1, the only solution is 3 pi over 2 plus multiples of 2 pi. Where k is some integer. Then we can simplify the solutions, and we have x equals to either pi over 12 plus pi k, this time just multiples of pi, not 2 pi, or 5 pi over 12 plus pi k, or 3 pi over 4 plus pi k. Now I'm going to rewrite 3 pi over k as 9 pi over 12. The reason that I do this is that if I write it this way, then the coefficients of pi, 1 over here, then 5 and 9 form an arithmetic sequence, while the denominator of these fractions are the same. So it's possible that I may use one single expression to cover all possible solutions. Now let's try to write a few more to see what kind of pattern do they form. The solutions we have are pi over 12 starting from k equals 0, 5 pi over 12, 9 pi over 12. Then I can move to k equals 1, and I have 13 pi over 12, 17 pi over 12, and 21 pi over 12. Now all the coefficients in these terms still form an arithmetic sequence, even I take the terms after 9 pi over 12. So altogether, we can actually say x is equal to something like 4n plus 1 times pi over 12, some integer n. So now we have two groups of solutions for each of the two equations. They are, on one hand we have x equals pi over 12 plus pi over 6 times multiples of pi over 6. I'll write like this. And on the other hand, we have x equals pi over 12 plus 4n pi over 12. I would write that as pi over 3 multiplied by n over here. The red for the first equation and the black one for the second equation. And I want to take the common terms, the common numbers among the two groups of solutions as our final answer. And in fact, since they are both pi over 12 plus some multiples of, I should say, fraction multiples of pi, and for these factors, one divides the other. Pi over 6 is exactly half of pi over 3, or I should say pi over 3 is exactly double of pi over 6. So I can just conclude by saying that our final answer, I can say that combining, final answer is x equals to pi over 12 plus some multiple of pi over 3. Where I specify that n is an integer in the solution. So this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.